Hello and welcome to my channel. In today's math tutorial, we shall be solving this SAT past question. If the product of ax plus 2 and bx plus 7 is 15x squared plus 6cx plus 14 and a plus b is 8, we have to find two possible values for c for all values of x. Before we go on, if you are yet to subscribe to my channel, please click the subscribe button now and click the notification bell so that you do not miss out on any updates from my channel. So we have that ax plus 2 times bx plus 7 is equivalent to 15x squared plus cx plus 14. We are going to distribute the terms in the parentheses on the left into the ones on the right, which means that we have abx squared plus 7ax plus 2bx plus 14 on the left, and this is going to be equal to the expression that we have still on the right. On the left, we factor x from the terms that have x, so that we have abx squared plus 7a plus 2b with x factored plus 14, and this is equal to 15x squared plus cx plus 14. Then at this stage we compare the coefficients on the left to those on the right. When we do, the coefficient of x squared on the left is ab, that's equal to 15 on the right. We're going to call that equation 1. The coefficient of x on the left is 7a plus 2b. This is compared to c, the coefficient of x on the right, as equation 2. And that equation 3 comes from the problem itself, where we were given that a plus b is 8. Thus, in order to get the two possible values for c, we'll need to solve equations 1 and 3 simultaneously to get the values of a and b, and after which we plug in the values of a and b into equation 2 to get the values of c. We shall be using the substitution method to solve equations 1 and 3. So from equation 3, we can make a the subject of the formula, where a is 8 minus b. We call this equation 4. Then we substitute equation 4 into equation 2. That instead of a, we put 8 minus b, then times b, and that's equal to 15. Distributing b on the left, we give 8b minus b squared equals to 15. Then we rearrange to have negative b squared plus 8b. Subtracting 15 will be minus 15 equals to 0. Multiplying through by negative 1, we have b squared minus ab plus 15 equals to 0, where the factors of positive 15 that will add up to negative 8 would be -3 and -5. So the expression on the left factors as b minus 3 times b minus 5 equals to 0. And by the zero product property, b minus 3 is 0 or b minus 5 is 0, meaning that b is 3 or b is 5. And we plug every value of b into equation 4 to get the corresponding value of a. Don't forget that equation 4 is a is equal to a minus b. So when b is 3, a is going to be a minus 3, which is 5. And when b is 5, a is going to be a minus 5, which is 3. That means that the solution pairs of a and b are 5, 3 and 3, 5. Now that we have the solutions for a and b, we can make use of equation 2 to get the values of c. Recall that equation 2 is 7a plus 2b equals to c. Hence, when a is 5 and b is 3, we shall have 7 times 5 plus 2 times 3 to be equal to c, which means that 35 plus 6 and that's 41 would be the first value of c. And likewise, when a is 3 and b is 5, 7 times 3 plus 2 times 5 will be the second value of c, which is 21 plus 10. That's 31. Therefore, the two possible values of c are 31 and 41. I have the belief that you enjoyed today's math tutorial. Let me know your thoughts in the comment section. You can also send in your questions to the comment section or to the email address attached to the description of this video. Don't forget to like and share this video. And if you are yet to subscribe to my channel, please do so right now. Click on the notification bell as you look forward to updates on my next activity from this channel. Thank you for watching this video and have a lovely day. Bye.